expressions and equations number 8. We're still analyzing a systems of equation. The great news is it is the final learning target of this standard. And in this one, there is 2 verbs we have to look at. So I can solve. So you're going to solve real-world problems dealing with the systems of linear equations, and you're also going to interpret them. So not only are you going to solve them like LT2 in whatever method you like, graphing, substitution, or elimination, you're also going to have to look at the answer, that ordered pair you get at the end, and you're going to say, hey, what does this actually mean? You're going to do that interpretation part. So we're going to look at 2 problems. So the first problem is going to be Henry and his mom are planting vegetables in their garden. Henry has planted or finished planting 3 rows of carrots so far and is planting new rows at the rate of 4 rows per hour. His mom has finished 11 rows of tomatoes and will continue planting at 3 rows per hour. Once the pair get to a point where they have finished the same amount of rows, they will take a break and decide what to plant next. So there's 2 things here. First of all, we have told you what X represents and what Y represents to help you out. So that's one thing you really need to focus on and pay attention to is, okay, what is the X value going to mean in my equations and what is the Y value going to mean in my equations? So in this one, the X value represents the time in hours and Y represents the total number of rows. The other thing I want you to pay attention to, go way to the bottom, is the question at the end. So you kind of understand what you're looking for. So in the end here, you're going to put in the blank here. Henry and his mom will have blank rows planted in blank hours when they get to take their blank break. So you're looking for how many rows they have planted and then at how many hours will that take. So you're comparing both Henry and his mom, and you want to know when they have equal number of rows and at what hours is that going to happen. So the first thing you're going to always have to do is you're going to have to write your equation. So we're going to stop and look at Henry's work first. So I go back into the problem here. It says, Henry has finished planting 3 rows of carrots so far and is planting new rows at a rate of 4 per hour. So when I hear that, I can hear myself saying, he's already planted 3. So those are 3 rows that are already planted, plus he continues to plant 4 rows every hour. And I'm going to look back up here and I know that X represents time in hours. So I'm going to just put 4X. So again, this means 3 rows that have already been planted, plus we don't know how many more rows, but we know he's planting 4 rows in every hour. And that is going to equal Y, how many total rows. So if he only plants 1 more row, we're going to put 1 more hour. He's going to put 1 here for X. So 4 times 1 plus 3 is 7. So he'll be able to plant 7 more rows in an hour. Or if he did 2 more hours, it'd be 4 times 2 plus 3. And that's how many rows. Mom, if we look at her details, it says his mom has finished 11 rows. So she already has 11 rows done. She's doing much more than her son at this point, but will continue to plant 3 rows per hour. So she's planting at the rate of 3 rows per hour. So Henry planted 4 rows an hour and Mom's planting 3 rows an hour. Henry only has 3 rows planted, Mom has 11. And that will equal how many rows she can get planted. So again, if she plants 1 hour, we'll take 3 times 1 plus 11. So she'll be able to have 14 rows planted. So we want to know what the X is, how many hours it's going to take them to plant the same amount of rows. So we're going to solve it with that system of equations. So we're going to make it look like a system here with our bracket. So Y equals 3 plus 4X. And Y equals 11 plus 3X. So I look at this, and I'm kind of looking at the way this is set up. I have choices. I can do elimination method, but it's not really set up nicely for elimination method. I could do substitution, which is what probably I'm going to do because it's nicely, or I could graph it. So if you want to graph it, you can go back into your pages 25 and 26 into your packet, and you can graph it on there. Or you can just use the substitution method to solve, which is what I'm going to do. So I'm going to, since I know that y is equivalent or equal to 3 plus 4x, I'm going to substitute it in for the other y. So I'm going to set the equations equal to each other. So I have 3 plus 4x, since that's my new y, and that equals still the 11 plus 3x. And I'm just going to solve algebraically here. So I'm going to take care of the x's first. So I'm going to get rid of the 3x's off of my right side, which will leave me with 3 plus an x equals 11. I could put 1 here if that makes more sense. And then I'm going to subtract my 3. So I get that 1x to equal 8. So x, which is the number of hours, so I know that they are planting for 8 hours. Now to figure out the other one, I'm going to plug that into either equation. I'll just pick the top one right now. So I got y equals 3 plus 4 times, instead of x, now I know how many hours, I'm going to put 8 there. So this is Henry. So y, how many rows he's planted, equals 3 plus, well, 4 times 8 is 32. So then y equals 3 plus 32, which we know is 35. So we know that in 8 hours, Henry will plant 35 total rows. And I'm going to check that with Mom's, just to make sure we get the same answer. This is my check here, even though it gave me my answer. Mom had 11 rows planted at 3 rows per hour, but I know now we're planting for 8 hours. So I have y equals 11 plus, well, 8 times 3 is 24. So I know that 11 plus 24 is also 35, which is a good sign because remember, this is just like the system equations. They have to give you the same y value. So they both work, and that's also my check. So now I can go down here and finish my interpretation. Since I know this is my many of hours, x is hours, and y is how many total rows they planted, I can fill in my blank. So Henry and his mom will have planted 35 rows in 8 hours when they get to take their break. That's a long time till they get to take the break. So I hope they're not hungry or thirsty or need to use the restroom. So notice as we do this, there's a lot of interpretation. I'm thinking a lot about the problem. It's just not the solving part anymore. It's really, what does the problem mean? What does my x mean? What does my y mean? Yes, we have to solve it, but the interpretation part is the real important part because technically, mathematically, that's what you do in the real world. You don't just solve these problems randomly unless you're going to be a math teacher. But if you're going to do it in the real world, you're going to solve them for a reason. And then you have to interpret what you're actually getting for answers. Let's look at number 2. The Hutchins family and the Kirk family are seeing a movie together. At the concession stand, Mr. Hutchins pays $9 for just 1 large popcorn and 1 large drink that his family will share. Mrs. Kirk pays for 1 large popcorn and 2 large drinks that her family will share, and she paid $14. So looking at what our x, because these are 2 things to get started with, just so what you're so you kind of know what you're working with. We're going to let x represent how much 1 popcorn cost and y represent what 1 large drink cost. I want to know when you go up to the concession stand and I look at the prices, how much does it say a popcorn is and how much does it say 1 large drink is? And then I'm going to go down here, remember, and I'm going to kind of see what my final question is, or I should say final answer. It says a large drink will cost blank and a popcorn will cost blank. So I want to know how much will a drink cost me and how much will a popcorn cost me? So I'm going to start here at the top. I'm going to make that equation. I'm going to start with the Hutchins family. So I'm going to go back through this. It says at the concession stand, Mr. Hutchins paid $9 in total. 1 for 1 large popcorn and for 1 large drink. So 1 popcorn, which is x. So 1 popcorn times I don't know how much value, plus 1 drink times how much the y, which would be how much it's going to cost for my 1 drink. It's going to cost me $9. And now I'm going to go through and look at Kirk family. They bought 1 popcorn and 2 large drinks, and they paid $14. So 1 popcorn times x, because that's how much it costs for 1 popcorn, plus 2 popcorns at times y, because we don't know what the cost of that popcorn is, but we do know that their total was $14. So I'm going to set that up like an equation with my bracket. So it's x, or 1x plus a y equals 9, and 1x plus 2y's equals 14. I'm going to look at this, go through my method choices. I could graph. I could plug in and out and go ahead and use, again, the graph paper in 25 and 26. I could eliminate. Substitution is really not helpful here because I don't have y equals or x equals. So I'm going to do the elimination process because it's already set up. The x's are set up nicely. The y's are set up nicely. So I'm just going to eliminate here. Now, I got to get opposite. So I can try to get rid of the x's, or I can try to get rid of the y's. It really mathematically doesn't matter. You just got to make that decision. I'm going to get rid of the x's. Just because I then have to only multiply times a -1. I'm just going to take the top one times -1 because I want these opposite coefficients. So I'm going to take this top value times -1, and that's going to change it to -x minus y equals a -9. And since I changed the top one, I don't have to touch the bottom one in this case because I already have opposite coefficients here. Because remember, that's a -1 and this is a +1. So I don't have to do anything to the bottom equation. And then I'm just going to go ahead and add. Good news, it cancels out or eliminates out. Hence the reason why I did what I did by multiplying times -1. -2y plus, -1y plus 2y does equal 1y, and that 1y equals 5. So that was pretty sharp and pretty quick there. I got to the answer of y equals 5. Now think back, what does y equal? Well, y is the cost of a drink. So I know that right now the large drinks cost me $5. So now I'm going to use one of my equations from the top. And I think it's easiest to use the top one because it was x plus y equals 9. Well, I know that the drink is already $5, so x plus $5 equals 9. And I could just look at that, or I could just go ahead and solve it with my algebraic steps. I can subtract 5 from both sides, and x equals 4. So I know that x, which go backing up here, is the cost per large popcorn. So popcorns cost me $4, and I know drinks cost me $5. Well, I'm going to do a quick check just to make sure that I'm right. I already checked it kind of with the Hudgens family because I can say 4 plus 5 equals 9, and I'm going to check it with the Kirk family. So I have one drink. I apologize. It's one popcorn. So one $4 popcorn plus 2 drinks at $5 each. I'm just inputting this equation just to check here. And it's supposed to equal $14. So 4 plus the 10 does equal 14. So I can guarantee you this is really the price of our popcorn and drink. So I go down here. I got to be careful when I do this. So I go back and look. Y is my large drink. So the large drink will cost $5 because y is 5. So that goes there. And the large popcorn will cost me $4. So just be careful of that bottom one, that it's not always x and y. It just has to depend on which variable represents what. I hope this is very helpful, and enjoy your Christmas break as soon as you get this learning target done.